So we're almost done talking about integration by substitution. I have just a couple more things I want to point out. And one of them is what happens when you have a bounds of integration. Let's say I want to do the integral of e to the x squared with, actually let's do, erase. Let's do e to the 3x squared minus 1 with an x out front. And let's say this is the integral from 0 to 1. And I need a dx. So I'm going to try doing a u substitution. I need to pick my u thing. I want u to be a thing that I see on the inside, whose derivative I kind of see on the outside. I might first be looking at 3x squared. The derivative of that is 6x. I have an x outside, and the 6 I can deal with myself. Hopefully I've done enough examples that I notice, hey, 3x squared minus 1, that's even better, and the derivative is still just 6x. The minus 1 can hop onto this ride for free. So that's what we'll try for our u. We're going to make u equal 3x squared minus 1, and now du is 6x dx. And if I do the shove something in trick where I wish there was a 6 here, and to fix that I'll put a 1/6 outside, I'm ready to do the substitution pretty smoothly. The trouble is, this isn't an indefinite integral, this is a definite integral, meaning it has the little numbers out here, where after I do the integral, my plan is to plug in the 0 and plug in the 1 and subtract. Okay, remember, a key difference between a definite integral and an indefinite integral is the answer to a definite integral is going to be a number. And when your answer is a number, this whole translate to French, translate to English thing, that's all kind of irrelevant. Like, I keep reminding myself I can't leave my answer in u form because my answer, the problem was given to me about x's, so I need to give my answer in terms of x's, and that means I need to undo the substitution. Well, in this case, the answer is a number, and a number doesn't care about u's and x's, and that sort of indicates, hey, I shouldn't have to do the substitution backwards thing. I can. If I do, the way that would go is something like this. The key thing is I need to remember not to be writing my bounds of integration along the way. So u becomes that becomes u. 6x dx all becomes du. I have an integral symbol and the 1/6 out front is still there. And I'm not putting the bounds of integration. Because if I've decided I'm going to do this the old way, the 0 and 1 are x values. In this context, I'm likely to write them as x equals 0 to x equals 1. They don't mean anything for you. If I'm not translating them, I need to suppress them. I need to not write them down. I need to finish the integral and then at the very end plug in 0, plug in 1, subtract. How would that go? The integral of e to the u is e to the u plus c. What was u? U was 3x squared minus 1. So I get 1/6 e to the 3x squared plus 1. And now I remember, hey, I didn't actually need the plus c because I'm plugging in numbers and subtracting. So now the thing I need to do is evaluate 1/6 e to the 3x squared plus 1 from 0 to 1. Plug in 1, I get e to the 3 1 squared plus 1 is 4. Plug in 0, I get e to the 3 times 0 plus 1 is 1. Hey, here's our answer. 1/6 e to the 4 minus 1/6 e to the 1. I can rewrite that as e. That's not much simplification. You will be tempted to get digits on this. I guess I can type it in and get digits on this. Dear calculator, what is, second, quit, 1/6 parenthesis, I'll factor out the 1/6, e to the 4, no, close parenthesis, minus e to the 1, close, no, e to the 1, close that parenthesis, close that parenthesis. I'm getting this as 8.6466. You'll be tempted to put a box around this answer. Most of the time you don't really want a box around this answer, because remember, our calculators can do definite integrals. We could have graphed this function and asked our calculator, hey, what's the integral from 0 to 1? And it would have given us the 8.6466. So getting the decimal answer is kind of not impressive. The thing you want to have is, like, the thing you want to show off is, hey, I didn't just get a decimal. I got the exact answer where that decimal came from. This is the part that's impressive, that proves that you did the calculus to do the work. If you put a box around the decimals, I'm not going to take points off, but make sure you're showing this, as long as you're showing that you actually did do the calculus. Okay, so that's doing it the old way, the less fancy, the less slick way. The thing we were trying to observe is that going back and substituting in the u's should be unnecessary. And here's what I mean by that. Our old integral, well, let's just pick up from where we were down here. This stuff becomes du. That e to the 3x squared minus 1 becomes e to the u. The 1/6 out front stays out front. And the new thing is we need to change these bounds of integration. This was x equals 0 to 1. X equals 0, 1 turns into u equals what to what? How do I answer that? Well, I answer that with the same equation that we were dealing with before. When x equals 0, what's u? Oh, wait. Was it minus 1 or plus 1? Dang, I screwed this up. Let's just make this a plus 1, because that's what I did on the other side. Sorry. When I did the problem over here, I made it x squared plus 1, and part of the point is to see that we get the same answer. Let's say the original problem was a plus 1. Sorry about that. When x is 0, what's u? I plug in x equals 0 to my u formula, and I get that x equals 0 corresponds with u equals 1. I'm thinking, what's u equals 3 times 0 squared plus 1? What's u equals 3 times 1 squared plus 1? Both of these are straightforward numbers to work out. This is u equals 1 to u equals 4. I'm going to integrate this function with respect to u and never have to go back to the x's. What's the integral of e to the u? It's e to the u. I still need to evaluate that from 1 to 4. I get 1/6 e to the 4 minus e to the 1. Which, hey, is the same answer in 2 less lines. I can get the digits on it if I want. And it's sort of obvious that we're going to get the same answer. It's just an issue of, do I wait until here to plug in the... How did that get erased? Do I wait until I get here to plug in x equals 0, or do we do it at the earlier step? Either of these is fine, but the key thing is when you get to this point, you need to not be writing 0 to 1. Like, if you're going to write any numbers, they need to be the correct numbers. Right. And if I'm just telling you to do the definite integral, then you can do it either way. Some of the problems, I'm forcing you to do it the grown-up sophisticated way, and it's because you're not actually doing the integral, you're converting the integral. And changing the bounds of integration is part of converting the integral. What I mean is, these are... Do I have it open? This is these problems. It says do this substitution on this integral. You don't have to finish the integral, but you have to do the substitution. This has bounds of integration, so changing those bounds of integration is part of doing that problem. Okay. Yeah, so that's definite integrals by substitution.